Hi there, this is Mrs. Often, and I'm reviewing one of my lessons today in order to help people out with the optional extra credit assignment for Math 109. Please keep in mind that in this optional extra credit assignment, you are asked to create a mini lesson that addresses a topic that we've discussed in class that could be of use in other classes. Your choices are any topic having to do with transformations or any topic from polynomials. Your lesson ideally is going to be short because it's a mini lesson, so you want it to last no longer than 10 to 15 minutes if you were to make a video. I'm going to review the lesson that I have on perpendicular and angle bisectors. And while I was going through it, I noticed some areas in which I was not achieving the goals that I had set forward for you in the rubric criteria. So I've updated those, and I'm going to point out how this relates to the rubric. So let's look at our first rubric criteria. Our objective: what is your lesson about? We want this to be exemplary. So the objective goal of the mini lesson stated using mathematical language and student-friendly language. Let's look at my lesson. Right here, my objectives are stated here. Prove and apply theorems about perpendicular bisectors. Prove and apply theorems about angle bisectors. So in good news, we did this proof in class for the theorems about perpendicular bisectors and angle bisectors. Our objective in this lesson really is just going to be to apply those theorems. So I think I did an effective job. In the video, hopefully you'll think that I did an exemplary job, but we'll get to that. Okay, our examples need to be related to the topic. You're going to see in this lesson, I have a whole lot of problems related to the topic, increasing in difficulty, and they're solved correctly. I did go through to check them. And I do think that they are increasing in difficulty through the section. I use mathematical language and I define it clearly for the students. And then I want to talk about misconceptions or errors. Now, I notice, again, in my slide deck that I did not do that, but in the video, hopefully you will see where I do point out some places where you could be making errors. So you may want to look at the video. If you're just submitting a Google slide deck and you're not making a video, I want to encourage you to put those in the notes section so somebody who is reading it can see where that might be and where they might make an error, or you can put it as a comment or a call out bubble on your slides. So here my objectives have been clearly stated. Here's an example of where I give a new vocabulary term and I define it. When a point is the same distance from two or more points, the point is said to be equidistant from the objects. And we have triangle congruence theorems that we will use to prove theorems about equidistant points. So I go on to use that definition in my perpendicular bisector theorem. And I have another mathematical term that I then define, locus. And a locus is a set of points that satisfies a given condition, and that the perpendicular bisector of a segment can be defined as the locus of points in a plane that are equidistant from the endpoints of the segment. So what I would recommend here is that in the notes section, and I can show my speaker notes right here, I can type in, remember, in video, tell students that we define the perpendicular bisector one way in chapter 1, but we extend that definition through using the term locus and with the perpendicular bisector theorem. So, okay, moving on. I have my example here, and I think this is a pretty easy example. I have this triangle. I can see that this is a right angle. It is a perpendicular bisector because it is perpendicular, and I can prove that these two triangles are congruent by using angle, angle, side. So I know that GF is the perpendicular bisector. DGF and EGF are congruent, therefore DF and EF are congruent. That means that if DE is equal to 20.8, DE is equal to 2EF, 20.8 is equal to 2EF, and 10.4 is the measure of segment EF. Now here, I also introduce what if we don't know that GFE is a right angle. So I'm going to put in my speaker notes, in video, be sure to remind students that they must know either that angle GFE is right angle, can use triangle congruence then to show GF is perpendicular bisector, or they must be told GF is perpendicular bisector, or we can be told that DF equals EF, or that F is the midpoint. So we want to remind students that a common mistake is that students just see a segment there, they don't see a right angle, they don't have this information, and then they make assumptions. We want to be careful in reading diagrams. Okay, so my next slide says the distance between a point and a line is defined as the length of the perpendicular segment from the point to the line. So another thing that could have happened in this prior that I'll add, or we could be told distance from point G to DE is along segment GF, and then we'll know that it's perpendicular. Okay. So I'm going to point out some potential errors right there. So here's another example, and you can notice this is a little bit harder because I have factoring involved. Here's my perpendicular bisector theorem. TU has got to be equal to TV because I see that UW is the perpendicular bisector of segment TV. So I substitute my given values. I could point out that students want to be cautious in factoring. Remember that I have to have different signs for 2 and 3 here in order for the product to be -6. I also want to point out that I do want to see both solutions listed and then to be told that that first solution is extraneous. So there's not going to be two different answers. There's just going to be one value for the length of TU and VU. So again, I'm going to put that note in here in my speaker notes. In video, remind students that you need to check for extraneous solutions and to be careful in factoring. Okay. So because this lesson goes on and talks about different topics, and you may have a lesson that is similar. So you may decide to discuss different types of reflections, and you may reflect, for example, across the x-axis and across the y-axis, and you have two problems of varying levels of difficulty, one with reflecting across the y-axis and one with reflecting across the x-axis. They're both easy problems. And then you have two harder problems. You have a total of 4 problems. and they have increased in difficulty, then I would for sure give you the 4 for activities related to the topics and they're getting harder. I do something like that here where I start out with an easier problem with angle bisectors, and then I have a harder problem with angle bisectors and an even harder problem. So, and this one I also want to note, this is not necessarily a common student error, but it is something that I've noticed people are grinding through proofs because they've forgotten about this important theorem that we proved at the start of the year. I'm going to say in the video, remind students that they can use half angle bisector theorem as well. So they can say that the measure of WYZ is, or 1/2 the measure of WYZ we can say that the measure of WYZ is equal to 1/2 the measure of XYZ because that is an angle bisector. So that could be very helpful. So we can use that there. So I hope this has been helpful to you in knowing how to maximize the points that you can receive on your optional extra credit assignment quiz grade.